This video is going to look at formulas and how we can use them to problem solve and find a solution to a particular problem. So formulas are used and they state a known relationship among multiple quantities. So there's lots of formulas that we use. Some we use on a regular basis. Some we use and we don't even know that we're really even using a formula. And these are just some examples. So we have the area formula of a rectangle. We can also have the area formula of any shape, any two-dimensional shape. Other things are this simple interest. So interest equals principal times rate times time. And then you have your perimeter formulas, which perimeter is an easy concept in the sense that we just add up all the sides, but we could write it as a particular formula. And then you can get into your volume. So volume is looking at three-dimensional figures. So we could look at volume. You could have a surface area formula. Again, multiple different formulas. Those are just a few examples. But so we're going to be looking at if we're given a formula, can we use that formula to determine an unknown or a missing piece of the equation? So let's look at this one first. So let's convert the temperature 5 degrees Celsius to Fahrenheit. So there's a formula for that. So if we want to convert Fahrenheit to Celsius or Celsius to Fahrenheit, we could use this particular formula. So it's F equals 9/5 times C plus 32. So if I want to convert 5 degrees Celsius, well, that 5 is representing a Celsius degree, so we're going to plug that in for the C. Sorry about that. So when I do that, the F stays. I have 9/5 times C. Well, now my C is 5, because that's what the problem states, plus 32. So I would go ahead and just solve that equation now that I only have one particular variable left, which is Fahrenheit. So 9/5 times 5, well, these cancel, that gives you a 9. Again, I did that in my head. You could use a calculator to calculate that for you. And then drop down the plus 32. Then at the end, go ahead and add the 9 and the 32, and you're going to get 41 degrees. So 5 degrees Celsius is equal to 41 degrees in Fahrenheit. Right? Pretty simple, not much to it. So let's look at this one. This one is a word problem giving a bit more context to it. So a family is planning their vacation to visit relatives. They will drive from Cincinnati, Ohio to Rapid City, South Dakota, a distance of 1,180 miles. They plan to average a rate of 50 miles per hour. How much time will they spend driving? Use the formula D equals rate times time. Okay, so we're given our formula. D equals rate times time. And let's see what we got. So it says a distance of 1,180. So that would go into where the D is. Then it says they plan to average a rate of 50 miles per hour. So that would go in where our rate is. And then the question says how much time. So that's our unknown. So that makes sense that T is the only thing left in that formula. So now I'm looking at 1,180 equals 50t. So let's solve for t and get time by itself. So we would divide by that coefficient of 50, divide by that over there. And that's going to give us 1,180 divided by 50, which gives us 23.6, which equals our t. Let me double check my math. Yep. Okay, that's what I got. So the time is going to be 23.6. So we could say that's 23.6. And again, because we're talking about miles per hour, this is hours. So if I want to travel 1,180 miles at an average rate of 50 miles per hour, I would be driving for about roughly 23.6 hours. Good. Okay, the next one. A wood deck is being built behind a house. The width of the deck must be 18 feet because the shape of the house. If there is 450 square feet of decking material, find the length of the deck, use the formula A equals LW. So we're talking about the surface of a deck, which is going to be looking at the area of that deck, and I'm assuming it will be a rectangular or square form. So let's figure out what we got. So it says the width of the deck is 18 feet, so that's going to go in here with our W. It says if there is 450 square feet of decking, so because that has a dimension of square feet, remember a square unit is always representing the area of a figure. So that right there, whether it said square feet, square inches, square miles, that square is going to indicate that that dimension, that 450, is going to be the area of that shape. Okay, so that's how I know it's going to go into that A in that formula. And then I'm left with this L. I'm going to make it a cursive L so it kind of stands out a little bit. So again, I would divide by that 18 to get rid of it. Divide by that 18 as well. So I got 450 divided by 18. I got 25. So the length of this deck is going to be 25 and the unit is feet. So this would be 25 feet by 18 feet, which would use up that 450 square feet of decking material. Okay. Okay, so I have a couple that I want you to do, but we're going to take these one at a time. So go ahead and pause it and try this this word problem here. And again, I give you the formula, so you're going to be using the formula P equals the sum of all sides. So that's a perimeter formula. So go ahead and pause it and see what you can come up with, and then play it to hear the explanation. Okay, so in this problem, the perimeter is 140, so I know it's going to go there. Okay, it's going to go in for that P. It says if the width of this garden is to be 30 feet, find the length. Okay, so again, if we want to just kind of visualize this, the width is 30, and then I'm trying to find this length. Well, don't forget that 30 and 30, that's two widths, and then there's two lengths. Okay, so this perimeter would actually be 30 plus 30, that's two widths, but then I have to add to it two lengths. Okay, so don't forget that. So that's 140 equals 60 plus, and then I have two L's. Okay, so that one might have been a little tricky if you forgot. We don't just have one pair of these, we have two. So we have to double the width and double the length to get to the perimeter of a rectangle. Okay, now I can solve this by subtracting 60, and that's going to give me 80 left. And then divide by the 2, and you're going to get a length of 40, and that would be 40 feet. Okay, so make sure you take note of this if you were kind of missing two of those sides. Good. All right, go ahead and try this one. It's another Fahrenheit and Celsius, and see what you can come up with. Go ahead and pause it. Okay, so the average maximum temperature for the month of January is 59 degrees Fahrenheit. Find the equivalent temperature in degrees Celsius. So we're going to use that same formula we used earlier, except now this 59 has an F with it, so I have to plug that in for the Fahrenheit and not the Celsius. Okay, so we'll subtract the 32, and that's going to give you 27 equals 9/5 C. Divide by the coefficient, so even though it's a fraction, don't let that change your process. Divide by the 9/5 there, so 27 divided by 9/5 would end up giving you an even 15. So that would mean 59 degrees Fahrenheit equals 15 degrees in Celsius. Good. All right, last one, and then we'll move on to the next objective. So go ahead and pause and try this. Okay, so the length of a rectangular road sign is 2 feet less than 3 times its width. Find the dimensions if the perimeter is 28 feet. Use the formula P equals sum of all sides. So again, let's go ahead and I'm going to draw a visual just so you can see, and then it might be clear if you made a mistake before we even get there. So it says the length is 2 feet less than 3 times the width. So this right here, 2 feet less than, then tells me to flip the order, so the subtract 2 comes last, and then 3 times the width, which is 3W, comes first. Okay, so again, remember you have 2 of those, and then we also have 2 widths, so the width we represented as W. So now we have just expressional pieces for all of them. So this would be a width plus a length, which is 3W minus 2, plus another length, which is 3W minus 2, and that would equal a total of 28. So that means I have 1, 2 W's, 5 W's, 8 W's, and then I have -2 and -2, which is -4. Okay, then we'll add the 4 to solve it. And that would give us 32, divide by 8, divide by 8, and you get W equals 4. So then that would mean your widths are 4, and that would mean your lengths are 3 times the 4 minus 2, which would be 12 minus 2, which is 10. And again, if you see, we got 4, 4, 10, and 10, and that gives you your total of 28. So that makes sense. Okay, so drawing a visual sometimes helps. It's okay to have expressional pieces for each of your sides, and then we can use concepts of solving equations to simplify the left side of this and then get W by itself. Alright, so the next objective we're going to cover in this video is still using formulas, but we're going to look at, if we give a formula, can we solve for another variable within it? So sometimes that's important for us to know how to do in case we have to manipulate that formula, so we don't necessarily have the A by itself, we have a W by itself or something in particular there. Okay, so we're going to use the same steps we use, the same concepts we use when we solve equations. So we want to be thinking opposite operations to get things from one side to the other. All right, so let's go ahead and look at some of these. So if I'm giving you the formula T equals MNR. Now, it doesn't matter if you know what that formula is. What this question is asking you is it wants you to solve for n. So notice T is by itself, but I don't want T by itself. I want this middle n by itself. Okay, so we want to manipulate this formula to get n equals something. Okay, so let's focus on this side of the equation right now. If I see M, N, R, all 3 of those are right next to each other, so that indicates multiplication. So if I'm multiplying all of those pieces, in order to move something from one side to the other, I do the opposite of what I'm already doing. So because I'm already multiplying, I want to divide. And I'm going to divide by the M and divide by the R. Because M divided by M is nothing, or 1, R divided by R is 1 as well. But then I have to do that same thing to the other side. So now I'm left with T over MR equals my N. And that is your answer. And I could flip that and write the N first, so it looks a little nicer. But that's in essence what it is asking you to do, to take a formula and then manipulate it to get another variable by itself instead of what is already by itself. Okay, let's look at this one. So I have y equals mx plus b. So this is slope-intercept form. So I want to get the x by itself now. Okay, so let's first take care of this plus b. So I could subtract b, because anything minus itself is nothing, and subtract b there. So I have y minus b equals mx. Now, I want x by itself, so let's divide by that coefficient of m, divide it over here. So notice as we go through these, I'm not getting rid of any variables, I'm just shuffling them around. And that would be your answer for slope-intercept form, but now getting x by itself. Okay, let's look at this one. So this one, I want p by itself. And notice that I already have two p's. Okay, so there's two p's there, but I can't do p plus prt because this has a rt, that p does not. Okay, so those are not like terms, so I can't add those. But what I'm going to go ahead and do, and this is the easiest strategy to do it, you could solve this a couple different ways, but I'm going to give you an easy technique to use in case this pops up. So if I take this whole side and divide by the p, that means I can divide out this p and I can divide out that p. Okay, and why does that help? Well, now p divided by p is 1 plus, and then when I take this out of this side, all I have is RT. Okay. Right, these are tricky ones, but this is a good example to have. But I'm not done because I don't have this p by itself, I have this a here. Okay, so what I'm going to do is multiply by p to get this out of the denominator. And I'm going to multiply this side by p. Okay, so now I have this. Right? Well, now if I divide this by that whole entire parentheses, I will come to my final answer. So that gives you a over 1 plus RT equals that p. Okay, so to recap that, if ever you want to solve for a variable that there's actually two of, okay, and they're separated by a plus or a minus sign, go ahead and divide that out first to kind of give yourself just one of them. But then if it's in the denominator, I'm going to eventually have to pull it out of that denominator. So I think that that's an easy second step to pull that out of the denominator then. And then I can divide by that whole entire parentheses. Again, not the easiest ones to do, but this is a good example to have down to refer to. Okay, so go ahead and try these three. You're just taking three formulas and solving for a given variable. Go ahead and try them, give yourself plenty of time, and hit play when you're done to hear the explanations. All right, looking at the first one, I want to get L by itself. So you would subtract this whole 2W first to get P minus 2W equals the 2L. Oops, sorry, not T. Okay. Then I would divide by this 2, and you get P minus 2W all over 2 equals L. Okay. All right, not a terrible one. All right, the next one, C equals 2 pi r. Okay, so again, because that 2 pi r, that's all multiplication, so I'm going to divide by the 2 pi to get rid of it. Divide by the 2 pi over here. So that's going to give you C, or circumference, over 2 pi equals the radius. Okay, this last one here is kind of like that principal rate time one that we had. So it's S equals 4LW plus 2WH, and I want to get W by itself. So because there's two W's, each in a term, I'm going to divide that out first. So that gives you S over W equals 4L plus 2H. Then I'm going to pull that W out of the denominator, and I end up with this. And then go ahead and divide by that whole entire parentheses to be done. So that's surface equals 4 times the length plus 2 times the width would equal, oh, I'm sorry, that's an H. It's like that doesn't make sense, equals the width. Okay, so again, just like that principal rate time one we did, so pull out the W, get that out of there, then take it out of the denominator, and then divide by all of that. Okay. Very good.